Okay, so next we're going to have to look how to use identities to calculate for trigonometric function. This is going to be the example of how we're going to use it. So for the example given over here, we're going to use identity to find cos theta and tangent theta. So given that sine theta is equal -3/5 and theta is actually an angle that is between pi and also 3 pi over 2. So that will be the idea. Okay, when it says over here, so the fact that we have to use identity, so which identity that we're referring to? So we're actually referring to one of this. So it's actually the identity that we see at the beginning, so which is going to be either one of this. Okay, so what we have is we are being given a value of sine, and then we are going to relate and find a formula that is going to relate for the case that how do we find cos from sine. And having a look at this particular identities right here, which we have 3 of them. So basically, so the identity that will relate between sine and cos is going to be this one over here. So the fact that sine square theta plus cos square theta, that is going to equal 1. So that is going to be the identity that I'm going to apply for this particular example. So let's get back to here. So let's add a page. Okay, so I'm going to use the fact that, so sine square theta plus cos square theta, so that is going to equal a value of 1. So here we've been given that sine theta is going to equal 3/5, and let me rearrange the equation a little bit. I'm going to write that, so cos square theta is going to equal 1 minus sine square of theta, and we already know, so the fact that the value of sine theta is going to equal -3/5. And we also know from what I have explained before, so this is actually equivalent to 1 minus sine theta raised to the power of 2. They are equivalent, they are the same thing. So now when I substitute, so I will end up with 1 minus, and sine theta is given by a value of -3/5 raised to the power of 2. And this is going to equal 1 minus 9/25. And 25 minus 9, so that is going to equal 16/25. So that is going to be cos square theta. But the thing is that we don't want cos square theta, but what we wanted is going to be cos of theta. So of course cos of theta is going to be square root over 16/25. So I'm not sure what's wrong with the pencil, seriously. So this is going to be 16/25 square root. So for which this could be either plus or minus 4/5. So that is going to be our cos of theta, because positive 4/5 is going to equal 16/25, and even negative 4/5 square is still going to be 16/25. So both of this value is going to give us cos square theta, which is 16/25. Okay, so now we have to think. It's either going to be one of that, or it could also be both, depending on the condition. Okay, what happens is that going to be a positive 4/5, or is it going to be a negative 4/5? So how do we decide on that? So how do we decide of that is going to be based on the condition given. And we are being given the condition, the fact that our value of theta is going to be between pi and also 3 pi over 2. Okay, if I were to sketch a graph, I've shown you this in the previous topic. So the fact that in terms of radian unit, this is 0. So this is pi over 2. So this is pi. This is 3 pi over 2. And it ends here. So this is going to be 2 pi. Okay. All right. So what happened is that our value of theta, so this is between pi and 3 pi over 2. So which is between these two. So it's between pi and 3 pi over 2. We know that theta is going to be over here. So that is in the third quadrant. And I have also explained this to you before, the rule of cos, the fact that here all cosines are going to be positive. So here all, whether it's going to be cos, sine or tangent, everything is going to be positive. And here sine only will be positive. And in the third quadrant, only tangent will be positive. Anything else, sine, cos, they are both going to be negative. So which is why, to improve here, so because, so theta is a value, so between pi and pi over 2, so which tells us, so this should be in the third quadrant. So I'm put over here, so third quadrant. I'm not sure what's wrong with my pen today. So in the third quadrant, so therefore, okay, So cos of theta is going to be negative because in this quadrant, so only tangent is supposed to be positive. So cos theta is going to equal negative 4 over 5. So that is going to be the outcome. So the question asks you to find the value of cos theta. So cos theta is going to equal negative 4 over 5. But that is not the only thing. The question also asks you to find what is going to be tangent of theta. So let me put down here. Okay, so tangent of theta, so according to the formula, so tangent is going to equal sine theta over cos of theta. And we already have the value from our calculation previously, that sine theta is going to equal negative 3 over 5. And cos from our previous calculation up here is going to equal negative 4 over 5. And if we were to simplify this, we'll get negative 3 over 5. So multiplied by negative 5 over 4. So this is going to cancel each other. And we are going to end up with a positive of 3 over 4. And we can actually verify that this is correct. The reason is that because theta is going to be in the third quadrant and it is a tangent, and here for the value of tangent we have a value of positive 3 over 5, so which should happen for this case because in the third quadrant, so tangent should be positive, so that is why it's going to be a value of 3 over 5. So that is going to be the particular example for this. So basically you are being given a value, so you're going to use one of identity and relate to whatever value that you need to find given in the question. Okay, so that will be the idea. Okay, and then next, this is exercise. So I've given you the solution, so please try to attempt the problem. Next, I'm going to talk about proving identity. And if you happen to have done additional maths during school, so this is something that we have learned already, and this will be pretty much the same idea. Okay, so I have two examples over here, so I'm going to show you both of them. But if you are already like very well versed with this topic, so there's no need for you to follow everything. So bring out a piece of paper, try to do it with me, and prove that you can actually get the same answer as well. Okay, and the thing about proving is that you have two sides of the equation. So one equation is going to be the left-hand side, which is referring to the one over here. So the other function is going to be on the right-hand side, which is the one that we have right here. So when it comes to proving, should we prove that right-hand side is equal left-hand side? Or should it be the other way around, that left-hand side is equal right-hand side? So actually the idea is, so it could be either one of this. So no matter what you did, both of them are correct. Both are correct as long as you actually prove that both sides should actually be the same after applying certain property. So whether you're going to prove that this one is going to equal secant x tangent x, or secant x tangent x is going to equal this fraction, so both of them are actually possible. So it is up to you, so which one you are more comfortable with. But usually what I will do is I will start with the more complicated one, okay, and I will prove the simpler function. So that is what I decided to do every single time, because I figured that so to change the more complicated to a simpler function is actually easier than doing it the other way around, which is starting from a simpler function and make it more complicated. So that is actually more complicated than the previous one. So therefore I always start with a function that is more complicated and I try to make it simpler. Okay, so this two over here, so which one is more complicated? So I find that the fraction is actually more complicated. Is this in the form of 1 over cosecant of x? So cosecant of x minus sine of x. So I find that this one is more complicated. So I'm going to start with this one. And I'm going to prove that this is going to equal secant x tangent x. Okay, the idea is, the first step that you should do is, anything that is not in term of sine, that is not in term of cos, which is referring to tangent, cotangent, secant, and cosecant. So please change everything to be in term of sine and also cosine. So for this case, I'm going to have 1 over. So the cosecant is going to equal 1 over sine of x. So this is going to be minus sine of x. Okay, now it looks more complicated, but we are done with the first rule, which is making everything to be in term of sine and cosine. Okay, now that I have this form, so I am going to simplify the fraction beneath. I'm going to simplify this. So the idea is going to be something like this. If I have a 1 over 2 plus 3, so how do I do the operation? So I'm going to make both of them in term of fraction. I'm going to write that this is actually 1 over 2 plus 6 over 2. And then only I can write this as 7 over 2. So that is going to be the idea that we're going to apply here as well. So therefore, what I'm going to do is, I'm going to write this as 1 over. So this is going to be 1 minus. So this is sine x. When I multiply that by another sine x, so it's going to be sine square x over sine of x. Okay, so instead of like having one fraction, one is not in term of fraction, so I apply this idea and make both to be in term of a fraction, and I put them together. So the operation is done. Okay, so that is what I wanted to achieve. Okay, so now that I have this form, I can simply flip it around, because this is 1 over. So this is actually equivalent to 1 division. So I have a division over here. So this is 1 over. So I'm going to flip it around and make it in terms of multiplication. So this is going to be 1 multiplied by sine x over 1 minus sine square x. Okay, and so when I simplified, this is going to be sine x over, sorry, it's a square over here, 1 minus sine square x. Okay, so that it was what happened when I simplified. So now my equation has started to become simpler and simpler, but the problem is that I haven't achieved what I wanted, so which is making it into this form, so which is secant x tangent of x. What I know for sure is that when we have secant, so we know that secant x is going to equal 1 over cos of x, but the problem is that I don't have any cosine terms in here. So how do I make it cosine terms? I'm going to use the identity, because I noticed that I can apply an identity over here. So using 1 minus sine square x, because according to what we have seen before, so sine square x plus cos square x, that is going to equal 1. So therefore, I can actually replace that. I can write that this is going to be equivalent to sine of x over underneath. So when I rearrange this, so 1 minus sine square x, so that is going to equal cos square of x. So that is what I'm going to apply. So that is how I ended up with cos square of x. And this, okay, how do I make it into the same form that I have up there? So I'm going to do is I'm going to write it like this. I'm going to write this as sine x over cos of x, so multiplied by 1 over cos of x. So according to what we had before, so I'm going to have secant x tangent x. So this part over here, so this is going to be my secant of x, and because it's multiplication, it doesn't matter which one comes first. So this is going to be secant of x. And this part over here, so sine x over tangent x, according to property, so we know that this is going to be tangent of x. So that is how we come across, so the fact that, so this fraction over here, 1 over cosecant x minus sine x, can actually be simplified to secant x multiplied by tangent x. So remember, so it's going to be easier if you start with a more complicated form and make it into simpler form. So that is going to be example number 1. So I'm going to show you example number 2 as well. So let's copy this down. And I'm going to add another page. Okay, so this is going to be for example number 2. So let me make that a little bit. So this is going to be example number 2. So I'm going to adopt the same idea for this one as well. So which one is more complicated? I noticed that the fraction ones are more complicated. I have 2 fractions, one fraction plus another fraction. And what I'm going to do is I'm going to simplify it to become 2 cosine of b. So now what I'm going to do is, first of all, so we have to make sure everything is in term of sine and cos. So there's nothing to do for this case because everything is already in term of sine and also cos. So we don't have to bother with that anymore. So now that I already have everything is in term of sine and cos, I'm going to put the 2 fractions together. So the idea is that if I would have 1 over a plus 1 over b, so how do I actually do the operation? So I'm going to multiply this top and bottom by a, sorry, it's going to be top and bottom, both are going to multiply by b, and this one I'm going to multiply both top and bottom by a. So that is how I'm going to end up with b plus a over ab. So this is going to be the same idea that I'm going to adopt for this case, but this one is going to be more complicated because of the more complicated function used. Okay, so here what I'm going to do is I'm going to multiply top and bottom by sine of b. So therefore I'm going to end up with sine square b, and at the bottom I'm going to have 1 plus cos b, so multiplied by sine b. So I multiplied top and bottom by sine b for the first fraction. Okay, for the second fraction, I'm going to multiply both top and bottom by 1 plus cos b. So when the top I multiply by 1 plus cos b, I'll end up with 1 plus cos b to the power of 2, because basically it's the same thing being multiplied twice. And at the bottom, I'm going to have sine b, so multiplied by 1 plus cos b. Okay, and of course, the denominator now are the same. So these two are actually the same, only the order is different. So I can actually put them together. So I can write that this is actually going to equal, so sine square b plus 1 plus cos square b, and sorry, it's going to be cos b square. I haven't expanded that, so let it be in that form first. 1 plus cos b square, and underneath I'm going to have sine b multiplied by 1 plus cos b. So now that both of the denominator are the same, then only we can put them together. Alright, so now what I'm going to do next is I'm going to expand this part. If you notice, I have a function of 1 plus cos b, both raised to the power of 2. So now let's start expanding the function, for which I will end up with sine square b plus 1 to the power of 2, that's a 1. And the middle term is going to be 2. So 2 multiplied by this, multiplied by that. So for which I will end up with 2 multiplied by 1, which is 2, multiplied by cos b. So I'll end up with 2 cos of b. And the last term is going to be cos b square, or that is actually equivalent to cos square b. And at the bottom, so it still remain. So I'm going to have sine b multiplied by 1 plus cos of b. Okay, so now that I have it in this form, so let me add another page. It wouldn't fit everything. So I'm going to do is I'm going to simplify whatever that I can on the top. And I noticed that there is something that we're familiar with. So the fact that at the top, I have sine square b plus cos square b. And we know that. So sine square b plus cos square b, so that is going to equivalent to 1. So that is why. So I'm going to put over here so that you know what I am doing. So sine square b plus cos square b, so that is going equal 1. So therefore I'm going to simplify. So I'm going to have 1 and 1, so that is going to equal 2. So I'm going to have 2 plus 2 cos of b, and underneath I'm going to have sine b, so multiplied by 1 plus cos of b. Okay, so that's how it looks like. And I noticed that, so both of the terms at the top actually has a common factor, so which is a value of 2. So I'm going to factorize the 2, for which I'll end up with 1 plus cos b at the top over, and at the bottom I'm going to have sine b multiplied by 1 plus cos of b. So this is the reason why I factorized the 2, because I noticed that if I were to factorize the 2, so these two, they are going to be the same, and I can actually cancel them. So this is going to leave me, so a fraction in the form of 2 over sine of b. So what does the question want? So we have to prove it in this form. And of course, so we know that 1 over sine of b, so is actually equivalent to 2. So cosecant of b, because cosecant of b is 1 over sine of b. So we have proven the fact that this fraction, this very complicated function, can actually be simplified to become a function of 2 cosecant of b. So remember I told you, so the idea of doing proving identity is that, so start with the more complicated one and show that it becomes the simpler function. And the first thing that you should do is change everything to be in terms of sine and cos, then only you proceed to doing the other operation, plus, minus, changing fraction, and so on. Okay, so that is the idea of how to do proving functions. And of course, I've given you a bunch of exercises for you to try over here, so have a go at them.